In part 1, we saw how to get points along a Bezier curve. Now, let's see how those points are spaced out along the curve. Here's a single Bezier segment. Rather than move one point along the curve, I'm going to draw lots of points simultaneously, but they're all going to be equally spaced in t. For example, if we wanted to move an object along this curve for 10 frames, we might pick values of t at 0, 0.1, 0.2, 0.3, 0.4, and so on, thinking that equally spaced values in t should give us equally spaced values along the curve, and so the object would move smoothly from one end to the other in equal steps. Let's see if that happens. So I'm going to put in 2 points, one at the beginning, one at the end. Now I have 3 points, and it looks like it's roughly in the middle, and I'll just keep adding lots and lots of points. Remember, these are equally spaced in t. And you'll notice 2 interesting things. First of all, of course, all the points lie on the curve. But more importantly, they're not equally spaced. In fact, in this example, they're much more spread out at the beginning and the end, and they're bunched up together in the middle. What this means is if we had an object that was moving along this curve and it moved from one dot to the next, it would move very fast at the very beginning. It would appear to slow down in the middle when it was taking smaller steps for every frame, and then it would speed up again at the end, which is the exact opposite of the kind of ease in, ease out that we often want from animation. This is nobody's fault. This is not an error of any kind. This is the way the mathematics of Bezier curves work, and it's just the nature of the beast. In fact, the way the points are spaced is very dependent on the shape of the curve and where the handles are located. When I move this handle very close to its control point, notice that the points bunch up. So I can get them bunched up at this end, and I can get them bunched up at that end, and now they're bunched up at the ends and spaced out more in the middle. This is really something that's very much dependent on the shape of the curve. So I'll tell you what, let me make this curve something very close to a straight line, as close as I can manage it. And you can see even here, they're spaced more at the ends. And if I pull this control point way down to the right, now they have a lot of spacing at the upper left, and then they bunch up, and then they space out a little bit more at the bottom right, and the motion would be very strange. Again, this has nothing to do with anything making a mistake. This is the way the mathematics of Bezier curves work. So if I kind of make this thing into a U shape, or an upside down U, you can see that they're bunched up in the middle, and for fun, let's see if I can make a loop out of this. Get these control points right where I need them to make a loop. And you can see we start with spaced out points at one end, they bunch up, and they get spaced out again at the far end. So what do you do about this? There are really 2 options. One is you use lots and lots and lots of points. So let's add lots and lots and lots of points here. And you make the curve not too sharp anywhere, and things will kind of look more or less uniformly spaced. As the curve gets sharper, though, you're going to begin to see differences. And here in the middle, they're all spaced together. Another thing to do is to cut the segment up into smaller pieces, and then each piece will probably be more or less uniformly spaced. A third option is to write a whole lot of code that will go through what's happening here and sort of correct for the mathematics and give you equally spaced points. You absolutely can write that code, but it's slow, and it will probably slow down your program. Here's a closed curve with many segments. I'll turn off the knots so we can see all the points a little bit more clearly, and tell you what, I'll even turn off the curve. And you can see that these points are just not that uniformly spaced. Now again, I can take many, many, many more points, and this will somewhat reduce the problem, but there's still nothing close to being equally spaced. The good news is that the spacing varies smoothly. So the object, even though it will appear to speed up and slow down, it'll never do so abruptly. You'll never see it suddenly jerk into motion and jerk to a stop. It will smoothly speed up and smoothly slow down. And in some applications, you may not even notice this effect. But if you do, the thing to do is to cut the curve up into more pieces, more smaller Bezier segments. And then each segment will have roughly a uniform distribution of points, and the object will appear to move smoothly. So here's everything you need to keep in mind. All you have to do is call Bezier point with the x's or the y's and the value of t, and you'll get back the x and y values of the point at that t. This one routine, Bezier point, is at the heart of everything we've seen in this video.